All right, in section 2.7, again, I'm going to split this into two sections so we get all the content. It's a really meaty section. But 2.7 is about assessing the model of the line, basically, and interpreting S, which is the standard deviation of the residuals. So let's look at this. Now that we've learned how to calculate a least square regression line, it's important to assess how well the line fits the data. We all said it's not perfect, but how well does it work? We do this by asking two questions. Is the line a right model to use, or would a curve be better? And if the line is a right model to use, how well does it make predictions? So we can use the residuals to assess whether a regression model is appropriate by making a residual plot. A residual plot is a scatter plot that plots the residual on the vertical axis and the explanatory variable on the horizontal axis. Okay, so let's look at one. All right, here's a scatter plot showing the relationship between the Super Bowl number and the cost of a 30-second commercial for the years 1967 to 2013, along with the least square regression line resulting. The resulting residual plot is shown to the right of the scatter plot. Now, so first, look at the scatter plot here. Okay, here's your scatter plot, and you can see it actually has kind of a curve to it, right? So, but this is the least square regression line that the calculator gave us. Now, we got to decide, is it a good fit? Well, our eyes tell us it's not, but sometimes it's not that obvious. So we use a residual plot, and the good news is you're going to be given a residual plot most every time you need one. But here's what's happening. They're taking this red line right here, the regression line, and putting it horizontally at 0. And then all these points that are above the line are above the line over here, above the line here, above the line here. And then these points below the line are below it here. Okay? So you're looking to see, is there a pattern in the way the numbers are above or below the line? Okay, so hopefully that makes sense. That's what the residual plot is doing. It's just taking the red line and making it the horizontal at 0, and helping you to see how these residuals fall. Above, below, are they scattered? Do they make a pattern? Those are the questions you're going to ask yourself. So let's look at this. To determine if the regression model is appropriate, you look at the residual plot. Okay, if there is no leftover pattern in the residual plot, the regression model is appropriate. The linear model is appropriate. If there is a leftover pattern in the residual plot, the regression model is not appropriate. Okay? So looking back up here for a second, notice how there is a pattern to this guy. There's a pattern. This guy makes like almost a parabola. There's a pattern, so that tells us that the linear model is not appropriate for this set of data. We need to use a different way to predict. You can just use a line. Okay? And that's all you have to be able to tell me at this point is it a good predictor or not? So let's try an example. Here's a scatter plot showing the Ford F-150 data from lesson 2.5, along with the corresponding residual plot. Look at the scatter plot and determine if the line is a good fit for the association. So we look at the scatter plot, and it looks okay, but our real indicator of if this line is a good predictor is the residual. So remember, it took that red line and made it horizontal, and then we look at how the points fall above and below it. Well, if you notice, there's not really a pattern here. It's an even scatter, which is a good sign. That's a good sign, because if it's no pattern at all, then the line is appropriate. Okay, so what we would say in our answer is this. The line is a good fit for the association. And you got to tell me why. Because there is no leftover pattern on the residual. Okay? It is a good fit because there's no leftover pattern in the residual plot. That's all you have to be able to decide. Okay? Now, once we have all the residuals, you can then measure how well the line makes predictions with the standard deviation of the residuals. And the calculator, thankfully, is going to do this for you. So here's the definition. Standard deviation of the residuals, which is S, measures the size of the typical residual. That is, S measures the typical distance between the actual values of Y and the predicted Y values. So to calculate standard deviation of the residuals, we square each of the residuals, we add them up, We divide by n minus 2 and then take a square root. So it's this big nasty formula, but the calculator's doing it for you. You don't have to do this by hand. I just want you to see that you have something to be thankful for. You don't have to calculate it. All right? So remember, it's finding the typical residual. How much are we typically off when we use this regression? Number 2, a random sample of 195 students was selected from the UK. Scatterplot shows the relationship between y, their height in inches, and x, their age in years, along with the least square regression line. The standard deviation of the residuals for this model is s equals 8.61. Interpret this value. Okay? So I'm going to show you how you need to interpret it using this example. Okay? So we would say that the actual height is typically about 8.61 inches away from the predicted height. Using the regression line with x equal age in years. All right, so this is what an example of the right response would look like. The actual height is typically about 8.61 inches away from the predicted height using the regression line with x equals age in years. So hopefully you can see that there's a framework here, and there are parts of this framework that are specific to the problem. For instance, the actual height is the response variable, right? Typically about 8.61, that's the S value, away from the predicted what height, using the regression line where x is equal to the age in years. So the yellow parts that I've highlighted are going to change from problem to problem. So you're going to have to read and be able to clearly tell me what was the response variable. Was it height? Was it price? What was it? And then obviously S, which will be given to you. And then X, you got to tell me what X was in that problem. What was the explanatory variable? All right? So this gives you a good framework for how to correctly answer any problem that asks you to interpret S.